Good morning. Today we are covering Geometry Lesson 7.3, which is identifying a dilation on a graph using ratios. And this video supports IL skills L13 and L14. So I want you to notice that we're going back to IXL for today. And a good question was asked in period 3 about, hey, are we going to be doing IXL, or are we going to be doing the Delta Math? And the answer is you're doing both, but you aren't doing them at the same time. So I'm not going to double up and have you have extra assignments. What I'm doing is I'm going to split what used to be exclusively IXL work into two buckets. So one will be IXL, one will be Delta Math, but they will both be weighted the same way. Okay. Again, remember to put your take notes, of course, take notes and put a header on your notes with your first and last name. And remember that I want your full first and last name, no aliases, no abbreviations. And put your date, period, and the lesson notes name and number into your lesson, and then into your notes. And then when you're done with that, you're to upload them to me. Now you can either use the Student View Dropbox, or you can email them to me, and that would be by 11:59 p.m. this Saturday. And Saturday happens to be January 9. If you do email them to me, then make sure you include in your email header all of this information that I asked for in your notes. I want to see them in both places. Okay, so what we're going to do now, we're just going to take a quick look at ratios, and then it kind of leads us into dilations. So you have this figure here, and this is a line segment that's broken into two subparts. So you have line segment AB and then line segment BC, and together they form line segment AC. And you know from the segment addition postulate that the two measures would add up and be the same. But I'm not asking for the measure of the two of AB or AC or BC. I'm looking for the measure of AC. So I want to know what is the ratio of AB to AC. So that's not exactly the same as measurement. I want to know the ratio. So what do we do here? We want to know the scale factor for AB. So, and the scale factor for AC. So what is the scale factor for AB? And so if you look at this, you can see that AB is 3 units. So the scale factor is is 3 units, or equals 3. Do it that way. Okay. And then AC, well, AC, you got to remember what BC is. BC, so we'll just do this. Scale factor of BC is 2 units. Right? But AB plus BC equal AC. So the scale factor of AC has to equal 3 plus 2, which equals 5. So the scale factor is 5. So now that tells you what the scale factor is of AC, but we want to know what the ratio is. Okay, so we know that the distance from A to B is 3 units. So it's we use its scale factor to come up with that, and that's 3 to the scale factor for AC, AC, which is 5. Okay, so this is the same as a ratio. So we just simply take the scale factors, of AB and AC as follows. So AB is to BC. Oh, I'm sorry, AC. AC as AB we said was 3 units, and BC we said, or AB is 3 units, and AC, which is what we're trying to get to here, is 5 units. So that is your ultimate answer. That's the ratio of AC, of AB to AC. Okay. So that answers our question. All right. Okay, so let's go on and let's work. Let's first look at some definitions, and then we're going to do an example. So during semester 1, we studied rigid transformations. Remember those? The image and the pre-image of a figure were congruent. In other words, they had the same size and the same shape. And in this lesson, you're going to learn about a non-rigid transformation called a dilation, in which the image and the pre-image of a figure are similar. That means they have a different size, but the same shape. That's the key criterion there. So if you look at the following, it says a dilation with a center of C. So here's C here and C here. And a scale factor of K. Okay. So is a transformation that maps every point P, so every point P, to a point P prime. So P is going to P prime, right? So that the following properties are true. So if P is not the center point C, then the image of P lies on CP. The scale factor K is the positive number such that K equals CP prime over CP, and K does not equal 1. Okay, so that's what we're looking at here. P is not the center, so let's find P. P is over here. It's not the center of C. It's not the center of C. Now, if P is the center of C, that's where it's in here. Here's C, here's P, and we're going out to P prime. So you got to look at these, and you're going to say, what on earth are they talking about? Well, what they're doing is they've got a triangle here, and they're measuring the distance from C to where prime is. And if you're enlarging, this is reduction. So let me restate this. This is prime, this is P. And remember, the image is always the figure that does not have the little tick marks, the prime marks, okay? So this is triangle PQR. And you're trying to reduce it to make it so it looks like P prime, Q prime, R prime. And so remember, when you're dealing with any rigid transformation, you started with an image. This is the image. And whoops, this is the pre-image. I'm just not on my game day. This is the pre-image. And this is the image. You start with a pre-image, which was the original figure, and since you're trying to reduce, the image is the smaller figure. So what they're saying is if P is not the center point C. So here's P. No, it's not the center point C because C is over here. Then the image from P to P prime lies on CP. Okay, so it does lie on CP. And so the scale factor is a positive number such that the, what's the K again? K is the scale factor. Okay, the scale factor here is formed by saying C to P prime divided by the whole thing, or 3 divided by 6, which is what shows here, equals 1/2. And so this is the scale factor, that K. Okay? If it is if it's an enlargement, you're starting over here, and PQR now is the smaller triangle. P prime, Q prime, R prime is the larger triangle. So if P is the center point C, P is the center point for C, then P equals P prime. All right? So C prime is divided by CP. I should say C to P prime. So C to P prime, all right, divided by CP. So C to P prime divided by CP. So in other words, 5 divided by 2 is the K factor, or the scale factor. Okay? So that's what you have to do. And so I know that this sounds a little kludgy, but look at the pictures and see what the pictures are doing and compare it down here. This is really the most useful information. C to P prime is from point C to point P prime, which is 5 units, hence 5 units in the numerator. C to P is 2 units, so the denominator is 2 units. So that's the scale factor for this enlargement, and you'll notice that it makes this fraction greater than 1. Okay? All right. So now that you see the general thing of what we're doing, what we want to do is we want to identify the following dilations and their scale factors. So if we look at the first one, A, you'll notice that the original triangle is the one that has P, point P in it. Okay, and P prime is where it's going to. So what are we doing? Are we making the pre-image larger, or are we making it smaller to the image? Well, the answer is we're making it smaller. Okay, so because, this is for A now, because C from C over here to P prime divided by C over P, the whole thing, equals, well, C to P prime is 2, and CP is 3. The scale factor is K equals, remember K means scale factor, equals 2/3. And since this is less than 1, so this is a reduction. Because K is less than 1. Okay? All right, let's look at the second one. So the second one, the original is the smaller figure, the smaller quadrilateral here. So we're using C to P again, or C to P prime. So we're going to start out by saying, because C to P prime, now notice the ratio is going to be the same over CP. So C to P prime, though, that's now the whole thing, equals 2, and C to P is just 1, 2 over 1. The scale factor is k equals 2 or 1. And this is an enlargement because k is greater than 1. Okay? So this is the information they're looking for, okay, with this kind of a problem. Okay, one more to go. All right, so here we have an XY coordinate chart. And they're telling us to draw a dilation of ABCD. So ABCD is this blue rectangle. And they give you the coordinates. So A is at 2, 2. So here's A, it's at 2, 2. B is at 6, 2. C is at 6, 4. And D is at 2, 4. Okay? So use the origin as the center and use a scale factor of 1 over 2. 1 over 2. So how does the perimeter of the pre-image compare to the perimeter of the image? That's the question. Okay. So if we look at this and we're going from A to A prime, we're going to want to figure out what the coordinates are for A prime. So A prime here, let's use this. A prime, what are its coordinates going to be? So think about it. If you're going to 1/2, this is a 2. This is what we've got. So k equals 1/2. So we're starting here at twice the size. That's the 2. So this has got to be half of that. So it's got to be 1, 1. And lo and behold, you see it's down here at 1, 1. And so then for B prime, it's at 6, 2. So the coordinates have to be halved. So you just simply multiply the coordinates by the scale factor. So in the first one, well, let's use the second one as our example. So 6 times 1/2 equals 3. So that's the x. The y is 2 times 1/2, which equals 1. Okay? So 3 over 1, or 3, 1, not 3 over 1, is your xy coordinate for B prime. And then C prime, half of 6 is 3, half of 4 is 2. And D prime, half of 2 is 1, half of 4 is 2. So those are your x and y coordinates for your new for your image after you've multiplied the coordinates of the pre-image times 1/2. Okay, and that's the process you're taking. So from the graph, you can see that the pre-image has a perimeter of 12. Now, how can you tell that? Well, just you look at the graph, and this is 1, and this is 6, so that's 6 units. Let me see here. X 2 to 6, 6 to 2. So this is 1, 2, 3, 4, 5. This is 5 units, I'm sorry. 5 units. And this is 5 units, that's 10. And then this is the pre-image. And this is 1, and this is 1, this is 1, this is 1. So that's 2 and 2. Is that right? I'm not sure if that's correct here, looking at this. Well, in any event, it is an image of 12, perimeter of 12. And so the ratio of the pre-image and its image is equal to the scale factor of the dilation. Okay? So, if you need to go back and figure out the perimeter on this, I think this perimeter is written down here wrong. This was given to me, and I'm looking at it, and I think it's wrong. So this is 5. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4. So that, yeah, this is 2 units, this is 2 units, this is 5 and 5. So 5 and 5 is 10, and 2 and 2 is 4, so 14. And the image has perimeter of, well, 1, 2, 3, 4, 5, 6. That's correct. Therefore, the ratio of the pre-image and the image should be equal to the scale factor. Well, that doesn't look right either. I'm looking at this right. Let's see. 1, 2. So let's make sure the coordinates were correct. That's 2, 2. This is x is 6, y is 2. This is x is 6, y is 4. This is x is 2, y is 4. Yep, those are correct. And then 1, 1, 3, 1, 3, 2, 1, 2. Yeah. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 units. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I was right the first time. It was 12. It's 12. So again, the perimeter has an image of 12. The perimeter's image, rather, to restate this. The image of the perimeter. One more time. The perimeter of the image, that's the blue square or blue rectangle, is 12 units. The perimeter of the image, that's the little red one here, is 6 units. So if you just simply take those two perimeters, 12 divided by 6 equals 2. But we're doing it the other way around. So the so it would be 6 over 12, which is 1/2. Okay? All right. So after fussing around with it, we've got it correctly done. And if you have any questions about this, you can see me in chat. I'm happy to talk about it with you. But basically, that's it. We're done, and we will see you later.